right, we're going to focus on parent functions today. A parent function is the simplest function with defining characteristics of the family. So you're going to hear about me talk about parent functions and their children, which are the changes from that parent. So today we're just talking about the parents, and then as we progress through our course, we'll see those transformations exist. So our first basic parent is the linear function. It's y equals mx plus b, so the slope of a line. So we have the identity, y equals x. So we're just going to be going ahead and evaluating the function like we've done already this year. So you go ahead and substitute right in here the x. So the input is -2. So the output will be -2. So as an ordered pair, that's -2, -2. So on our graph, we go left 2 and down 2. Input -1, output -1. So -1, -1. We graph it, left 1, down 1. Input 0, output 0. So order pair is 0, 0, what is also called the origin. Input 1, output 1. So 1, 1. Right 1, up 1. Input 2, output 2. So 2, 2. And then we connect our line. This is a continuous function. So the domain is all real numbers, and the range is also all real numbers. The next parent is the absolute value. So the equation is y equals the absolute value of x. So we're going to input those same numbers in for x, like we did on the last parent. So the absolute value of -2, when we input that in, we get a +2. So our ordered pair is -2, 2. So left 2, up 2. The absolute value of -1 is +1. So the ordered pair is -1, 1. The absolute value of 0 is 0. So we're at the origin. The absolute value of +1 is 1. So 1, 1. Absolute value of 2 is 2. So 2, 2. And what the shape of this graph looks like is what I call a V shape. The domain is all real numbers. The range of values is everything from this horizontal line, so everything from 0 and higher. So we say y is greater than or equal to 0, or in an interval notation, from 0 to infinity. Inequality, this would be x greater, oops, not greater than. This would be -infinity to infinity. Our next parent is our quadratic. Its equation is y equals x squared. So we're going to input those same numbers. So -2 squared is 4. So the ordered pair is -2, 4. -1 squared is 1. So -1, 1. 0 squared is 0. So again, we're at that origin. 1 squared is 1. So 1, 1. 2 squared is 4. So 2, 4. When we connect these points, this is not going to be a V. It's going to be the shape of a U. It's going to have that curve. So we call this U-shaped. So nice U. the domain and the range are the same as your absolute value. So it's everything above that yellow line there. The cubic function. The shape of this I call the S shape or snake. So we're going to evaluate the function. So -2 times -2 times -2 gives us a -8. So -2, -8. Then -1 times -1 times -1 is -1. So -1. -1. 0 times 0 times 0. Oh boy. Zero cubed is 0, so we're at the origin. 1 times 1 times 1 is a positive 1, so we're at 1, 1. And then 2 times 2 times 2 is 8, so right 2 up 8. So we connect those points, creating a nice shape of a S or snake. The domain and the range of this is just all real numbers, -infinity to infinity. Rational function. I'm going to go ahead and put our restrictions. So we're going to have some what we call asymptotes along the x-axis and the y-axis. So x cannot be 0, y cannot be 0. So those are going to be our domain restrictions. There are asymptotes. So the domain of this is -infinity to 0 or 0 to infinity. And then same thing with the range, -infinity to 0 or 0 to infinity. Here is why. We cannot, I substitute all these numbers in here. Right here, this number right there makes it undefined. You cannot put a 0 in the denominator of a fraction, so we call this undefined. So that makes this asymptote right there. Now if I simplify those fractions, -2, -1/2, -1, -1. So I'm going to go left 2, down 1/2, left 1, down 1. So that's going to create this curve if we approach those red lines. That's why I graphed the asymptotes first. Now we're going to go ahead and evaluate for 1 and 2. So we get 1/2, 1. So we get 1, 1, that should be a 1 there, and then 1, 2, 1, and then 1/2. So when we graph those, there's our 2 points. And again, those points are going to go right up against the red asymptotes. Our last function is called our radical. You cannot take the square root of a negative number. If you want to take a pause and input that into your calculator, -2 with a square root, it's going to give you an error message. That's not possible. Or if you substitute -1 into a square root, not possible. So that's where there's a domain issue. So x has to be greater than or equal to 0, so positive numbers is what we're looking for. So we substitute square root of 0 in. We get 0, 0, square root of 1. We get 1. Square root of 2. Now we're going to an approximation of about 1.4. Now I'm going to jump ahead and add one more x input. The square root of 4 nicely gives an output of 2. So 4, 2. Let's go ahead and graph it. So 0, 0, 1, 1, over 2, 1.4, over 4 up 2. So there is our graph. Our range of values is y is greater than or equal to 0.